Ancient builders achieved a perfection in stone that our modern tools cannot replicate. These lost architects left behind structures so precisely cut and impossibly heavy that their methods remain a complete mystery. We will journey to sites like Sacsayhuamán in Peru and the Baalbek platform in Lebanon, places where multi-ton stones are joined without mortar and fitted with a precision that defies explanation. By the end of this exploration, you will see human history and our own technological confidence in an entirely new light. How did these builders move blocks weighing hundreds of tons? And why did their advanced knowledge seemingly vanish from the earth? What does it truly mean to be an advanced civilization? These creators are called lost for a reason. Their names, their language, the very story of their people has been erased from history. We are left only with their impossible stonework. When we study the Romans or the Egyptians, we have records. We have lists of pharaohs, we know the names of engineers, we can trace the slow evolution of their building styles from simple to complex. But for these lost architects, their finest work seems to appear suddenly, fully formed, as if their knowledge had no beginning. There are no toolkits left behind at these sites, no discarded prototypes, no skeletons buried with honors that tell us who they were. The stones are the only record they left. They are both the question and the answer, a silent testament to a skill so profound it defies our understanding of the past. This profound anonymity forces us to look closer, to read the story told not in ink, but in mineral and precision. The mystery of who they were is inextricably linked to the deeper mystery of how they achieved such mastery. These architectural wonders are not confined to a single continent or culture. They are scattered across the globe, from the high Andes of Peru to the coastal waters of Japan. In the Peruvian highlands, the fortress of Ollantaytambo presents a breathtaking puzzle. Its walls are assembled from colossal stones, each one weighing as much as several modern trucks. These giant blocks are not simple rectangles. They are complex polygonal shapes, cut with such geometrical perfection that they lock together without a speck of mortar, forming a stone tapestry that has withstood centuries of earthquakes. Far across the Pacific Ocean, off the coast of Japan, lie the submerged terraces of the Yonaguni Monument. Its massive, angular platforms and sharp, clean steps are carved from solid bedrock, now resting silently beneath the waves. The structure's origins are a complete mystery, suggesting a chapter of human history now lost to the sea. Then there is the profound isolation of Easter Island, where the iconic Moai statues stand guard. These towering figures were carved from solid volcanic rock in a single quarry, then somehow transported for miles across the island to their final resting places. In India, the Colossal temple presents another kind of marvel. It is not a structure that was built upward, stone by stone. Instead, it was carved downward, a complete temple complex excavated from a single mountainside of granite. Workers removed an estimated 3 million cubic feet of solid rock, not by adding blocks but by the breathtaking act of subtraction. What connects these distant and seemingly unrelated sites? They all operate on a scale that dwarfs ordinary human effort. They all feature stones joined with a precision that seems to mock our understanding of ancient tools. And at every single one, the builders left no written manual, no definitive explanation for their methods. This global footprint implies something profound. It suggests a shared understanding of stone, a common knowledge of geometry and engineering that somehow crossed oceans and continents long before our conventional history says such travel was possible. This was not a single lost civilization, but perhaps a lost school of thought, a way of working with the earth that appeared in different corners of the world, only to fade silently from memory. High above the modern city of Cusco, the fortress of Sacsayhuamán presents a stone puzzle on a monumental scale. Its walls are not simple barriers. They are a series of dramatic, zigzagging ramparts assembled from colossal limestone blocks, some weighing as much as 200 tons. That is the weight of several fully loaded semi-trucks, lifted and positioned with breathtaking care. But the true marvel is not just their mass, it is their impossible fit. Each stone is a unique, irregular polygon, shaped to interlock perfectly with its neighbors in a three-dimensional jigsaw puzzle. The joints are so precise that you cannot slide a piece of paper between them, and no mortar was used. The entire structure holds together through gravity and geometry alone. These walls have endured for centuries, surviving countless earthquakes that have toppled later Spanish colonial buildings in the valley below. The stones, it seems, are designed to dance with the earth. During a tremor, they shift and settle, then lock back into place when the shaking stops. This is engineering that anticipates seismic activity, a deep understanding of both material and environment. Local tradition credits the Inca with its construction, and they certainly used the site. Yet the construction style itself tells a different, older story. The foundational walls, with their cyclopean stones, are unlike any other Inca architecture. The Inca were master stonemasons in their own right, but their work typically uses smaller, more regularly shaped blocks. The technique seen at Sacsayhuamán appears to be the work of an earlier, far more mysterious culture, one that had already perfected this method long before the Inca Empire rose. How did they achieve such perfection? The surfaces are so smooth they feel almost polished, as if finished by modern machinery. Yet mainstream archaeology tells us they had no iron or steel, only stone and bronze tools. To quarry, shape, and transport these giants would have required more than just vast numbers of workers. It would have demanded a profound, almost intuitive knowledge of physics, leverage, and logistics. The very existence of these walls forces us to ask if we have underestimated the technological capabilities of our ancestors. What knowledge did they possess that allowed them to work with stone not as a stubborn material, but as a fluid one to be shaped and placed with such confidence? Yet the precision of Sacsayhuamán is rivaled by the sheer, breathtaking mass of another ancient site. In Lebanon's Bekaa Valley, the Baalbek temple complex presents a different kind of mystery, one defined by weight on an almost unimaginable scale. Here, a massive retaining wall known as the Trilithon is assembled from 3 limestone blocks, each one estimated to weigh over 800 tons. To put that into perspective, that is heavier than 2 fully loaded Boeing 747 airplanes. These colossal stones are positioned high up in the wall, fitted together with such exactness that their joints are nearly invisible. How could anyone lift 800 tons of solid rock and place it with such care without the cranes and hydraulics of our modern world? The puzzle only deepens in a nearby quarry where an even more massive stone rests partially detached from the bedrock. Known as the Stone of the Pregnant Woman, this single block weighs an estimated 1,000 tons. It was cut and prepared for transport, but for reasons lost to time, it was never moved. Its existence proves that the builders were not just planning to work with these giants, they were confident they could move them. The Romans later built their own magnificent temples directly on top of this cyclopean platform, clearly utilizing the work of a far older, more advanced culture. The foundation was already ancient when the Romans arrived, a gift from a forgotten past. The engineering required here exceeds anything the Romans themselves documented. It forces us to question everything we think we know about pre-Roman capabilities. How were these megaliths quarried, transported, and lifted into place? The sheer physics involved has led to fascinating, if speculative, theories about lost lifting mechanisms, or even the use of sound or vibration to somehow make the impossibly heavy stones manageable. Baalbek stands as a silent, monumental challenge to our historical timeline, a place where the stones themselves ask a question we still cannot answer. But the precision of these ancient sites reaches its peak, or perhaps its breaking point, at a shattered plateau in the Bolivian highlands. Puma Punku is not a structure you look at in awe, but one you sift through in disbelief. The site is a sprawling field of architectural chaos, a collection of shattered andesite and red granite blocks scattered as if by a giant's hand. These are not simple stones. They are finely crafted components, each one a geometric masterpiece. We see perfect right angles, razor-sharp grooves, and complex interlocking channels carved into a stone so hard that modern masons would need diamond-tipped tools to work it. The pieces look less like ancient masonry and more like parts of a giant, sophisticated machine, or a modular building system designed for assembly. Some of the slabs feature drill holes that are perfectly cylindrical, bored straight through the dense rock with no visible tool marks. It is the kind of precision you would expect from a computer-controlled machine, not from artisans working with primitive tools. The sheer complexity implies a level of technical drawing and planning, a knowledge of advanced geometry and engineering that simply should not exist in its supposed time frame. The true mystery of Puma Punku is not just how these blocks were made, but what they were meant to become. The site's destruction, possibly by a cataclysmic event, has scrambled the blueprint, leaving us with the scattered pieces of a puzzle we can no longer comprehend. We are left staring at the fragments of a lost technology, wondering what incredible structure was being assembled and what kind of mind could have conceived of such a design. The very substance these builders chose tells a story of its own. They did not work with soft limestone or easy sandstone. They selected the most challenging materials on Earth, igneous rocks like granite, diorite, and andesite. These stones were forged in fire, born from the intense heat of the Earth's interior, making them incredibly dense and hard. On the Mohs scale of mineral hardness, which ranks materials from 1 to 10, these rocks sit near the top. They are so tough that they would quickly dull the copper and bronze tools that mainstream history suggests were available. Trying to carve intricate patterns into granite with a soft copper chisel would be like trying to carve a block of steel with a butter knife. The result would be a ruined tool and a barely scratched surface. Yet, at sites like Puma Punku, we find surfaces on this incredibly hard andesite that are flawlessly smooth, with grooves cut as cleanly as if made by a modern saw. How was this possible? Modern engineers trying to replicate this work have found that simply hitting the rock with harder stones, a technique known as pecking, is far too slow and crude to achieve the razor-sharp edges and perfect flatness we observe. To get these results, you would need something more advanced. You would need saws armed with diamond-hard abrasives to slice through the stone. You would need a kind of lathe to create those perfect cylindrical holes. Some researchers have even suggested something akin to ultrasonic machining, where high-frequency vibrations effortlessly carve hard materials, a technology we consider modern. But if such tools existed, where are they? Not a single example of a powered saw or an advanced drill has ever been found at any of these sites. There are no workshops filled with this mysterious machinery, no tool fragments, no discarded blades. We are left with a profound disconnect. The finished product screams of sophisticated technology, yet the archaeological record offers only simple hand tools. This gap is the heart of the mystery. The consistency of the work is another clue that points to something beyond individual craftsmanship, across a single wall or among thousands of scattered blocks, the finish is identical. The angles are the same, the grooves share the exact depth and width, the surfaces have the same smooth polish. This level of uniformity suggests a standardized process, a form of mass production. But how do you mass produce stonework without the machines that make mass production possible? The stones themselves stand as silent, stubborn evidence of a capability that, according to our current historical narrative, should not have existed. What kind of knowledge allows a culture to master stone so completely that they can treat it like a soft, pliable material, shaping it with a precision we would struggle to achieve even today? The very process of quarrying these stones presents its own separate mystery. To free a block weighing hundreds of tons from the living bedrock requires more than just brute force. It demands a kind of surgical precision. At the ancient quarries of Baalbek and Aswan, we see the evidence of this lost art. Here, massive blocks were not simply broken loose. They were carefully defined, their outlines cut into the solid stone with clean, sharp seams that look less like chisel marks and more like the work of a colossal cookie cutter. The surfaces of unfinished obelisks and partially detached blocks show tool marks that are incredibly fine and regular, grooves that would be impossible to achieve with the soft copper chisels or simple stone hammers we typically attribute to these eras. Trying to carve such clean lines into granite with those tools would be like trying to slice a loaf of bread with a wet noodle. The tool would deform long before the rock would yield. So how was it done? One compelling theory involves the use of plant-based acids. Certain plants contain chemical compounds that can, over time, soften the crystalline structure of hard rock, making it possible to then scrape it away. It is a slow, deliberate process, but it could explain the smooth, almost polished surfaces we find on quarried stone. Another, more speculative idea points to thermal shock. This involves heating the stone surface with fire and then rapidly cooling it with water, creating microscopic fractures that make the rock easier to work. Yet the precision of the cuts we observe seems to rule out such a crude method, as it would be difficult to control. The most fascinating proposals venture into the realm of sound. Could these builders have discovered a way to use specific sound frequencies, a form of acoustic resonance, to temporarily alter the state of the stone, making it more pliable or even causing it to separate along a predetermined line? While it sounds like science fiction, the concept would explain the impossible precision and the lack of any conventional tool marks. The logistics alone are staggering. Extracting a 1,000-ton block like the stone of the pregnant woman without it cracking under its own weight implies a deep, intuitive knowledge of geology. The builders would have needed to understand the natural fault lines within the rock, the points of stress and weakness, as if they could see right through the stone itself. They were not just miners, they were master geologists. Unlocking the secret of how they quarried these stones is the first key to understanding their entire architectural process. It suggests a beginning where raw, unshaped mountain was tamed not with overwhelming force, but with an almost gentle, knowing touch. Once you have a stone block weighing more than a commercial airliner, the next challenge is simply moving it. The logistical puzzle of transporting these megaliths across miles of rugged terrain is a question that has baffled researchers for generations. Conventional explanations suggest the use of wooden rollers, sledges pulled by large teams, and lubricated earthen ramps. Yet these methods begin to strain under the weight of the evidence. How do you move an 800-ton block without the wooden rollers splintering into dust under the pressure? How do you pull a sledge without leaving deep, permanent drag marks in the landscape, marks which are conspicuously absent at places like Baalbek? The pathways to these sites show no signs of such colossal traffic, and the stones themselves show no damage from being dragged or dropped. it is as if these giants were floated into place. This disconnect has given rise to more speculative yet fascinating alternative theories. Some researchers point to ancient legends that speak of a lost science, a way to make stones lose their weight. Could there have been a form of acoustic technology, using specific sound frequencies to create a resonance field that effectively levitated the blocks? Other hypotheses explore the idea of geopolymer chemistry, suggesting the stones were not quarried at all, but were instead cast on site from a liquid stone slurry, a kind of advanced concrete that was poured into molds. This would explain the perfect seams and lack of transport marks, but then struggles to account for the unique mineral signatures that prove the stones were, in fact, quarried from distant locations. The most compelling clue may be the sheer silence of the archaeological record. There are no graveyards of broken sledges, no immense piles of discarded rollers, no remnants of the massive infrastructure that such conventional methods would have demanded. The absence of this evidence is, in itself, a form of evidence. It suggests that the true method was so efficient, so clean, and so advanced that it left no trace behind. We are left to wonder if the real secret was not brute force, but a profound understanding of natural forces, a knowledge that allowed these architects to command gravity itself. The joints between these stones are so precise they form what is known as a dry fit. No mortar was used because none was needed. The stones lock together so perfectly that their seams are often called knife-edge joints, where not even a sliver of light can pass between them. This is not just a testament to careful cutting, it is evidence of a deep, intuitive understanding of structural integrity. The builders designed these walls to be dynamic, to flex and sway during an earthquake, with each uniquely shaped block redistributing the immense forces and then settling back into its original, perfect position. This is engineering that anticipates chaos and builds resilience directly into the stone. Modern analysis with laser scanning technology has revealed the staggering truth of this precision. The surfaces of these ancient stones are flat to within a tolerance of 1/100th of an inch. That is a level of accuracy we associate with the calibrated machines in a modern manufacturing facility, not with hand tools from a forgotten age. How could such a standard be achieved and maintained across thousands of individual blocks? The geometry itself provides another clue. Look closely at a wall like the one at Sacsayhuamán, and you will see stones that are not just flat. Some have subtle convex curves on their outer face, while the stones adjacent to them feature matching concave surfaces. This creates a powerful interlocking effect, a three-dimensional puzzle that resists being pulled apart. To design such a feature requires more than a good eye. It implies a knowledge of advanced mathematics, of concepts like radii and tangents, and the ability to draft these complex shapes before a single stone was ever cut. This consistency points to something we would recognize today as a standardized system. There must have been a universal unit of measurement, a set of master templates, and a rigorous quality control process to ensure every single component met the exact same high standard. This was not the work of individual artisans, each using their own ruler. It was the work of a culture that had industrialized perfection, achieving a level of craftsmanship that unified art, science, and engineering into a single, enduring legacy. But these stones were not only grounded in the earth, they were also aligned with the heavens. Across the globe, these mysterious structures function as monumental astronomical observatories, their stones pointing with silent accuracy to the sun, moon, and stars. The Great Pyramid of Giza, a structure often spoken of in the same breath as these other enigmas, is oriented to true north with a deviation of just 1/15th of a single degree. To achieve such precision, its builders would have needed a sophisticated understanding of the Earth's rotation, and the ability to conduct incredibly accurate land surveys, a feat that seems to defy the presumed technology of its time. Far to the north, on the Salisbury Plain in England, the ring of Stonehenge captures the first light of the summer solstice sunrise, a dramatic event that still draws thousands of spectators each year. These are not random alignments, they are deliberate, repeated features that require generations of careful observation, a long-term scientific project to map the cycles of the cosmos. This celestial knowledge was then literally set in stone, fused into the very architecture. The builders were clearly more than just engineers. They were master astronomers who viewed the sky as a fundamental part of their world. Why go to such extraordinary lengths? The integration of astronomy suggests these sites served a purpose far beyond the practical. They were likely centers of cultural and spiritual life, where the movements of the heavens were linked to agricultural cycles, ceremonial practices, and a profound cosmic belief system. The stones themselves became a permanent calendar, a way to mark the passage of time and connect the community to the greater universe. This celestial connection adds a profound new layer to their sophistication. It reveals a culture that saw no separation between science and spirit, one that built its most enduring monuments as a bridge between our world and the cosmos above. The stones themselves hold a geological memory, a silent testimony to the climate they have endured. At the base of the Great Sphinx of Giza, the weathered limestone body is not scarred by wind and sand, but by the distinct vertical undulations of water erosion. These deep, flowing channels could only have been formed by thousands of years of heavy, sustained rainfall. This presents a profound chronological puzzle, because the climate of Egypt has been overwhelmingly arid for the last 5,000 years. For the Sphinx to exhibit such marks, it would need to have been standing exposed during a much wetter period, potentially pushing its origin back to a time before 7,000 years ago, an era that predates the very civilization credited with its creation by millennia. This is not an isolated anomaly. High in the Andes, the same telltale signs appear on the ancient stones of Peru and Bolivia. The foundational blocks at sites like Sacsayhuamán and the scattered ruins of Puma Punku show identical water weathering, a pattern that suggests they too were shaped by a climate that has long since vanished. Geologists continue to debate the exact cause, whether from torrential rains or catastrophic flooding, but the implication is staggering. If this water erosion hypothesis is correct, then the timeline of advanced megalithic construction must be rewritten. It points to a forgotten epoch, a period lost to our historical records, where another culture with profound architectural skill left its mark on the world. What does this mean for our story of human progress? It suggests that the rise of civilization may not be a single, linear ascent, but a story with multiple chapters, some of which have been completely torn from the book. What kind of global event, what immense cataclysm could have erased not just a people, but the very memory of their existence, leaving only their rain-battered stones to whisper of their passing? Perhaps the most captivating theory suggests these builders commanded a force that leaves no physical trace. Sound. Across various ancient cultures, legends persist of priests or builders using specific chants, songs, or instruments that could make colossal stones light as air, allowing them to be guided into place by hand. These are not just isolated fairy tales, but a recurring motif that hints at a forgotten branch of physics. Modern experimental archaeology has begun to explore this possibility, demonstrating that resonant frequencies, a specific and powerful vibration, can dramatically affect physical matter. In laboratory settings, researchers have shown that applying the right sonic vibration to a heavy object can reduce its apparent weight and the friction it experiences, making it far easier to move. This principle, known as acoustic levitation, is not magic, it is science, though it remains a highly specialized and poorly understood field even today. The idea that an ancient culture mastered this knowledge is staggering. It would elegantly solve so many of our logistical puzzles. How do you move an 800-ton block without leaving drag marks? You do not drag it, you float it. How do you carve intricate patterns into granite without leaving tool marks? You do not carve it, you soften it with sound until it becomes as pliable as clay. The evidence for this is not confined to legends or labs. It is etched into the stones themselves, or more precisely, into the spaces between them. On the Mediterranean island of Malta, the hypogeum of Hal-Saflieni offers a profound clue. This subterranean labyrinth, carved from solid limestone, features a unique chamber now called the Oracle Room. When someone speaks in a deep, male voice within this room, the sound is amplified and transformed. The entire chamber resonates, vibrating with a powerful, low frequency that can be felt physically in the bones. This is not a random acoustic fluke. The shape of the room, the curvature of the walls, and the specific dimensions were engineered to achieve this effect. The builders of the hypogeum clearly understood acoustic principles on a level that we are only just beginning to appreciate. They designed a space where sound itself became a tangible, manipulable tool. If sound could be harnessed to shape a room, could it not also be used to shape the very stones that built the room? This theory of sonic architecture provides a compelling, if unproven, answer to the riddle of the missing tools. It suggests a technology that was both incredibly powerful and completely non-invasive. When the work was done, the only thing left behind was the perfectly fitted stone. The tools were the voices in the air, the vibrations in the ground, a knowledge that vanished when the last practitioner fell silent. What kind of world might it have been, where the air itself hummed with the power to build and to move mountains? Yet another radical idea emerges from the mind of a modern chemist. What if the stones themselves are not what they seem? French researcher Joseph Davidovits proposed a theory that turns traditional archaeology on its head. He suggests that many of these colossal blocks were not carved from solid rock, but were instead cast in place like a kind of ancient, advanced concrete. This is the geopolymer theory. Imagine taking local limestone, grinding it into a fine powder, and mixing it with a natural alkaline binder, perhaps derived from plant ash. The result would be a thick, liquid stone slurry that could be poured into wooden molds, packing it layer by layer to form what appears to be a single, massive block. This single idea could elegantly solve so many puzzles. It would explain the seamless, knife-edge joints, as liquid stone could be poured to perfectly match its neighbor. It would account for the bizarre, complex polygonal shapes, which would be simple to create with a custom mold but incredibly difficult to carve from solid granite. It even offers an answer to the transport problem, as you would only need to move bags of powdered rock and buckets of liquid, not 800-ton monoliths. The evidence for this is not just theoretical. Microscopic analysis of stone samples from the Great Pyramid of Giza has revealed features that are difficult to explain through natural quarrying. Some samples show air bubbles, organic fibers, and a rapid, non-uniform crystallization process, all of which are hallmarks of a cast, reconstituted material, not a stone that was slowly formed over geological time. Of course, this theory remains fiercely debated within mainstream archaeology. Critics point to the sheer volume of material needed and the logistical challenge of producing such vast quantities of geopolymer on site. Yet, if even partially true, the implications are staggering. It would mean these lost architects had mastered a form of chemistry and material science that we thought was a modern invention. They were not just moving mountains, they were, in a very real sense, growing them. This knowledge would represent a different path to technological advancement, one based on a deep understanding of the Earth's chemistry rather than on metal tools and machinery. Why does this matter? Because it forces us to expand our definition of what is possible in the ancient world. The Geopolymer theory challenges a fundamental assumption that every massive stone was hewn from a quarry. What if, for some of the most mysterious sites, we have been looking at the evidence all wrong? What if the stones are not carved but cast, not found but formed? These ancient stones are not the only records left behind, for the echoes of the builders can also be heard in the voices of their descendants. Across the world, cultural legends passed down through generations speak of these master architects, not as ordinary humans, but as gods, giants, or divine craftsmen. The Inca spoke of Viracocha, a mysterious, bearded god who walked among them, teaching the very arts of civilization, including the impossible skill of fitting stones together without mortar. Far across the world, ancient Sumerian tablets describe the Anunnaki, powerful beings who descended from the heavens and were said to build their structures with impossibly large stones. In the Mediterranean, Greek myths tell of the Cyclopes, a race of one-eyed giants credited with constructing the massive walls of Mycenae. At first glance, these are just fantastical stories, the stuff of folklore. But when we look closer, a pattern emerges. These myths, separated by vast oceans and millennia, all describe a similar event, the arrival of a powerful, knowledgeable group that possessed building skills far beyond the local population. Why would cultures with no known contact with each other all invent stories about outsiders who were masters of stone? It seems less like coincidence and more like a fragmented, global memory. These tales may be the oral history of a real encounter with the lost architects themselves, their extraordinary abilities so far beyond the norm that they could only be explained as divine or supernatural. The common threads are impossible to ignore. The figures in these legends are almost always teachers, imparting knowledge of agriculture, astronomy, and masonry. They are depicted as peaceful civilizers, not conquerors, and their most defining characteristic is their power over stone, an ability to command rock as if it were soft clay. By cross-referencing these myths, we are not just studying fairy tales, we are piecing together a global puzzle of forgotten innovation. The legends become a kind of cultural fingerprint, pointing toward a shared historical reality that our conventional timelines have missed. What if the story of Viracocha is not just a myth, but the Incas' way of remembering a real, flesh and blood master mason from a forgotten era? What if the tales of the Anunnaki preserve the memory of a highly advanced culture that once walked the earth? Decoding these stories is our best chance to give a name, and perhaps a face, to the ghosts who built our world's most enduring mysteries. The silence of these abandoned quarries and half-finished structures speaks to an ending as sudden as it was complete. This global vanishing act of architectural genius leads us to a single, haunting question. Was the knowledge of these master builders erased by a planetary catastrophe? Geological evidence from around the world points to a period of immense turmoil roughly 12,000 years ago, a time known as the Younger Dryas. This era saw the planet's climate lurch violently, with temperatures plummeting in a geological instant. Some researchers point to layers of sediment containing minerals that only form under extreme heat, suggesting the possibility of a fragmented comet striking the Earth's atmosphere, triggering fires, floods, and a long, cold winter. Imagine the world these builders inhabited suddenly turning against them. Skies darkening for years, familiar landscapes submerged by rising waters, and their sophisticated society collapsing under the weight of a global emergency. In such a scenario, the meticulous art of fitting 1,000-ton stones would become a forgotten luxury. The survival of the community, not the perfection of its architecture, would become the only priority. The very layers of earth at these ancient sites tell a story of disruption. At many locations, archaeologists find a clear strata of clay or silt, evidence of massive flooding, directly beneath or within the foundational layers of the megalithic structures. Other sites show vitrified stone, a type of rock that has been fused into a glass-like state, something that requires heat intense enough to melt the very surface of the stone. These are not the slow marks of time, but the sudden scars of disaster. If a cataclysm of this scale did occur, it would elegantly explain the greatest puzzles we face. It clarifies why such advanced techniques vanished without being passed down. It explains why later cultures, like the Inca or the Romans, found these monumental platforms and walls already in place, so far beyond their own understanding that they could only attribute them to gods or giants. The survivors of such an event, struggling to rebuild, would have seen these indestructible ruins as relics from a divine age, the work of their legendary ancestors. Their own oral histories would naturally morph into the myths of Viracocha and the Cyclopes that we hear today. This theory connects the dots between cosmic events and human history, suggesting that our technological journey may not be a straight line upward, but a cycle of rise and fall, of knowledge gained and then tragically lost. What does it mean for us if civilizations can reach such heights, only to be reset by the unforgiving hand of planetary change? Our most advanced engineering firms, armed with modern science, have tried and failed to match their work. Teams of archaeologists and engineers have conducted ambitious experiments, attempting to replicate the ancient feats using only the tools we believe were available. They have used copper saws dragged back and forth for days, with sand and water as abrasives, and yes, they can eventually cut a stone, but the process is agonizingly slow, and the resulting cut is rough and uneven, a far cry from the flawless, mirror-smooth surfaces found at Puma Punku or the knife-edged joints of Sacsayhuamán. The sheer speed and precision of the original work remains completely out of reach. Moving the stones presents an even greater challenge. Attempts to transport multi-ton blocks using wooden rollers, ropes, and large teams of people have often ended with broken equipment and the sobering realization of just how much friction and weight are involved. Moving an 800-ton block like those at Baalbek using these primitive methods is not just difficult, it appears to be a physical impossibility. The wooden rollers would be crushed into pulp long before the stone moved an inch. These repeated failures are not just minor setbacks, they are profound data points. They highlight a glaring gap between our understanding of ancient technology and the tangible reality left behind in stone. The evidence on the ground suggests the builders worked with an efficiency and confidence that our recreation teams completely lack. It is as if we are trying to solve an advanced physics problem with a primary school education. We are missing a fundamental piece of the puzzle. Perhaps the key was not in the hardness of their tools, but in a different understanding of the stone itself. Could they have used a chemical agent to soften the rock temporarily, making it pliable for shaping? Or did they harness a form of vibrational energy, a technology that manipulates matter on a subatomic level, a science we are only now beginning to explore? Every failed modern experiment deepens the mystery and forces a humbling conclusion. These lost architects did not just have different tools, they possessed a different kind of knowledge altogether, a school of physics and engineering that has since vanished from the earth. What fundamental principle of our world did they understand that we have somehow overlooked? These carvings are not random decorations. Etched into the granite and limestone of these ancient sites, we find a second language beyond the architecture itself, a symbolic code left by the builders. At Göbekli Tepe in Turkey, a site that rewrites our entire timeline for civilization, massive T-shaped pillars are covered in a menagerie of finely carved creatures. Vultures, scorpions, foxes, and snakes intertwine in a complex dance of stone. To the modern eye, they might seem like primitive art, but their placement is far too deliberate. Researchers suggest these animal forms could be a symbolic representation of the night sky, mapping out specific constellations as they appeared over 10,000 years ago. The entire complex, then, might not be just a temple, but a monumental observatory and a creation myth told in rock, a story of how the world began according to its creators. This transforms the purpose of the structure entirely. It was not merely a place for shelter or community gathering. It was a three-dimensional library, its walls holding a philosophical and astronomical knowledge system meant to endure for ages. The very act of building was an act of preserving their worldview. We see this same drive for encoding meaning across the globe. In the temples of ancient Egypt, the walls are not blank. They are covered in hieroglyphs and bas-reliefs that do more than just tell stories of pharaohs. They document advanced mathematical principles, astronomical cycles, and complex spiritual beliefs about the soul's journey. The Great Pyramid is not just a tomb. Its precise dimensions and celestial alignments suggest it is a model of the northern hemisphere of the Earth, scaled down with incredible accuracy. The builders were embedding their understanding of the planet and the cosmos directly into the architecture. This dual purpose, the marriage of practical function and profound symbolism, is the key to understanding their immense effort. Why go to such extraordinary lengths to move a 200-ton block? Because that block was not just a piece of a wall. It was a single sentence in a sacred text written for the ages, a text meant to withstand the erosion of time and the fall of empires. The precision of their stonework was not just an engineering goal, it was a spiritual one. A perfect joint was a reflection of cosmic order, a way to harmonize the human world with the divine. The geometric patterns repeated at sites from Mexico to Cambodia are not merely aesthetic. They are visual representations of universal laws, of sacred geometry that these cultures believed underpinned all of creation. The flawless fit of the stones was a physical manifestation of this belief in a perfectly ordered universe. This layer of symbolic meaning forces us to reconsider the very definition of a building. For these lost architects, a structure was never just a structure. It was a vessel for knowledge, a bridge between earth and sky, and a permanent record of what they held most sacred. Their legacy, therefore, is not only in the stones they left behind, but in the silent, waiting message carved upon them. The silent stones are finally beginning to speak, not in words but in data. When geologists place a sample under a microscope, they are not just looking at rock, they are reading a geological passport. Through mineralogical analysis, they can pinpoint the exact quarry a stone came from, sometimes tracing a block at a site like Stonehenge to a source many miles away. This reveals invisible highways of trade and transport, proving these builders commanded not only stone but vast logistical networks. It also highlights a deeper mystery, for at other sites, like the foundational layers of Baalbek, the stone is local, suggesting a profound mastery over the immediate environment. The secrets are not just in where the stone came from, but in what has happened to it since. Analysis of surface weathering, of the subtle ways water and wind have interacted with the mineral composition over millennia, provides a separate clock, one that sometimes challenges our established historical timeline. This geological testimony offers hard evidence that complements the tales told by pottery shards and carbon dates. Meanwhile, physicists approach these structures not as relics, but as engineered systems. Using advanced computer modeling, they can simulate immense forces, applying virtual earthquakes to the digital recreations of these ancient walls. The results are consistently astonishing. The complex interlocking joints, the subtle curves and angles, all function as a sophisticated shock absorption system. The simulations show stress flowing through the wall in a distributed web, rather than concentrating at a single point of failure. A modern concrete wall might crack under such strain, but these polygonal puzzles are designed to dance, to shift and settle without collapsing. This is not accidental genius. It is the product of a deep, empirical understanding of load distribution and structural dynamics, principles we thought we discovered only recently. This collaboration is where the real magic happens. The geologist's data on local stone hardness informs the physicist's model of how much force was required to shape it. The physicist's stress analysis explains why the geologist finds so little earthquake damage at these specific sites. Together, they are building a data-driven picture of the construction process itself. For instance, the consistent finish and perfect flatness of the stones, verified by laser scans, suggest the use of a master jig or template system, a form of quality control that ensured every component met the same exacting standard. This points to a society that valued standardized production, a concept we associate with the industrial age. No single field holds the master key to this mystery. The archaeologist unearths the context, the geologist reads the stone's story, and the physicist deciphers the engineering principles. It is only when these threads are woven together that a richer tapestry emerges. This integrated approach is slowly eroding the old divisions between science and history. We are learning that the question is not whether these builders had advanced technology, but what form that technology took. Perhaps their greatest tool was not a chisel, but a holistic worldview, one that saw no separation between the nature of the stone, the forces of the earth, and the mathematics of a perfect joint. What other insights are waiting to be unlocked when we finally learn to listen to all these disciplines at once? Beyond the physical mastery of stone lies a hidden layer of intellectual genius, one written in the silent language of mathematics. The proportions of these ancient structures are not arbitrary. They are precise mathematical equations rendered in granite and limestone. When modern researchers measure the angles and dimensions of the Great Pyramid of Giza, they find constants like pi and the golden ratio embedded directly into its fundamental geometry. This is not a matter of chance. The pyramid's base perimeter relates to the circumference of the Earth, and its height correlates with the planet's radius, scaled down by a precise factor. This suggests its builders possessed geodesic knowledge, an understanding of the Earth's spherical form and size that our history books claim was discovered millennia later. How could an ancient culture know the dimensions of the entire planet? This mathematical sophistication points to something far beyond simple engineering. It implies a fully developed system of calculation and measurement, a numeracy used not just for building, but for encoding a worldview. The same sacred geometry appears at sites separated by vast oceans. The angles of a temple in Cambodia might mirror the proportions of a pyramid in Mexico. The layout of Stonehenge in England reflects the same astronomical and geometric principles found in the temples of ancient Egypt. This is not a coincidence. It is the fingerprint of a universal mathematical language, a shared way of seeing the cosmos that connected cultures we thought were worlds apart. The builders were using numbers to describe the fundamental patterns of the universe, and they were building those patterns into the very fabric of their most sacred spaces. Decoding this numeracy is our only way to access their intellectual achievements. Why would they go to such lengths to hide advanced math in their architecture? Perhaps because they saw numbers as sacred as the building blocks of creation itself. For them, a perfect pyramid was not just a stable structure, it was a model of a perfect cosmos, a physical prayer written in the language of mathematics. The stones were their parchment, and their chisels were their pens, recording a knowledge so profound we are only just beginning to read it. The sheer consistency of these architectural marvels forces a difficult question. Could the scattered stones across the globe be the ruins of a single, forgotten chapter in human history? The theory of a lost mother culture, a civilization advanced enough to influence societies from Peru to Egypt, offers a compelling, if controversial, narrative. This idea, often whispered in the name of Atlantis, suggests that a global network of builders once shared a common knowledge of astronomy, geometry, and stonework. According to this view, a catastrophic collapse, perhaps the very one that left water erosion on the Sphinx, erased this society from memory. The survivors of this event would have scattered, carrying fragments of the old knowledge to emerging cultures, who then incorporated these advanced techniques into their own myths and monuments. This would explain why the foundational layers at sites like Baalbek are so much more advanced than the later Roman temples built upon them. It clarifies why the same sacred geometry and celestial alignments appear in cultures separated by oceans. The theory connects the dots between the impossible precision at Puma Punku, the colossal scale of Baalbek, and the astronomical genius of Giza into one cohesive story. Of course, mainstream archaeology remains deeply skeptical, pointing to the lack of any direct evidence for such a civilization, like cities, tools, or written records. But proponents counter that we are looking for the wrong things. A culture that mastered geopolymer chemistry would leave no quarries. A society that used sound or resonance as its primary tool would leave no physical implements behind. Their most enduring legacy would be the structures themselves, designed to withstand the very cataclysms that erased all other traces of their existence. Evaluating this idea requires a careful balance. We must separate the tantalizing speculation from the hard archaeological facts, while acknowledging that the facts themselves point to a profound mystery. The evidence does not necessarily demand a single, globe-spanning empire. It could instead suggest a school of knowledge, a way of thinking about the world and its materials, that was discovered independently in different times and places, only to be lost and rediscovered again. Yet the possibility remains haunting. What if our timeline of human progress is not just incomplete but fundamentally wrong? What if the pyramids and the polygonal walls are not the beginnings of engineering, but the faded echoes of a much older ending? This framework does not provide easy answers, but it reframes the entire mystery, transforming a collection of puzzling sites into potential chapters of a single, lost story. Later cultures saw these sites not as ruins but as foundations. The Inca, masters of empire in their own right, deliberately built their most important temples upon the older, indestructible walls they found at places like Sacsayhuamán. They recognized a superior craft, a strength they could not replicate, and so they integrated these mysterious platforms into the heart of their own sacred architecture. To them, these were the works of the Viracochas, the divine beings from a previous age. This was not merely reuse, it was an act of reverence, a way of connecting their own power to a legacy they could not fully comprehend but deeply respected. In Egypt, the Great Pyramids at Giza stood as eternal monuments for the pharaohs, yet the sheer perfection of their construction was a standard that later dynasties struggled to match. Over centuries, Egyptian pyramid building slowly declined in scale and precision. The knowledge of how to align a structure to true north with such breathtaking accuracy, or how to move and place multi-ton casing stones, seems to have faded, becoming a legendary skill of the Golden Age. The techniques were not entirely lost, but they were diluted, their original engineering principles perhaps replaced by ritualized practices whose deeper meanings were forgotten. This pattern of preservation and loss echoes through secret societies and guilds. The medieval stonemasons who built Europe's great cathedrals operated within closed lodges, guarding their geometric secrets and construction techniques as sacred knowledge passed from master to apprentice. Was this simply a trade guild protecting its livelihood, or was it the faint, structured echo of a much older tradition? The precise stonework and sacred geometry seen in Gothic architecture suggests that fragments of this ancient understanding survived, repackaged for a new era and a different faith. The Renaissance, with its rediscovery of classical learning, saw architects like Brunelleschi studying Roman ruins not just for their form, but for their hidden engineering principles, unlocking secrets of dome construction that had been dormant for a millennium. This transmission was always fragile. An interrupted apprenticeship, a guild dissolved, a library burned, or simply the slow erosion of oral tradition over generations could sever the chain forever. The knowledge did not vanish in a single dramatic moment, but rather seeped away drop by drop until only the stones were left, silent and perfect, waiting for a time when we would look upon them again and wonder what we had forgotten. The idea that these stones were placed by otherworldly hands is a compelling story, but it does a profound disservice to the people who actually built them. When we attribute these wonders to aliens or gods, we are essentially writing off human potential, dismissing the very real intellect and perseverance of our ancestors. The truth is, the evidence on the ground points not to magic, but to a science so refined it appears magical to our modern eyes. Archaeologists have uncovered the remnants of massive labor camps near these sites, evidence of highly organized societies capable of mobilizing thousands of workers. They have found simple tools like stone hammers and copper saws that prove the work was human. The real mystery is not who did it, but how they achieved such perfection with what we perceive as limited means. This is not a gap filled by fantasy, but by a lost branch of applied knowledge. Think of it like this. If you showed a smartphone to a person from the 19th century, they would likely call it sorcery. Our understanding of physics and engineering would be completely alien to them. The same principle applies in reverse. We are looking at the results of a technology we do not yet fully grasp, and our first impulse is to label it as impossible, rather than to question the limits of our own understanding. The builders likely possessed a deep, empirical knowledge of materials, leverage, and acoustics that we are only beginning to rediscover through our own experiments. By focusing on the plausible, we open a far more fascinating door than any extraterrestrial myth could provide. We start to see the outlines of a forgotten human achievement, a testament to what people are capable of when knowledge is pursued with relentless dedication. This grounded perspective does not diminish the wonder, it enhances it. It transforms these sites from passive relics of a mysterious past into active challenges, a call to re-examine our own capabilities and to wonder what other incredible chapters of human history are still waiting to be read in the stones they left behind. This seamless integration with the landscape reveals a philosophy far removed from our own. Modern construction often fights against nature, leveling hills and redirecting waterways to suit a blueprint. The lost architects, by contrast, seem to listen to the land, designing their structures as an extension of the earth itself. High in the Andes, the citadel of Machu Picchu is a masterclass in this approach. Its agricultural terraces are not merely stacked fields. They are a complex, multi-layered system designed to work with the mountain. The terraces prevent the thin, precious soil from washing away during heavy rains, while their stone-retaining walls absorb heat during the day, releasing it slowly at night to protect crops from frost. This is not just farming, it is a form of geoengineering that stabilized the slope and created a sustainable food source for centuries. The entire city is laid out to follow the natural contours of the ridge, its buildings and plazas nestled into the shape of the land rather than imposed upon it. This deep, intuitive understanding of the ecosystem is echoed in how they managed water. Sophisticated channels and fountains still guide fresh spring water through the site, a gravity-fed network that provided for both practical needs and ceremonial purposes. The builders were not just placing stones, they were weaving their architecture into the hydrological and geological fabric of the mountain. What does this tell us about their values? Their goal was not to conquer the environment, but to collaborate with it. They sought a balance that would ensure their creations endured not in spite of nature, but because of it. In our current era of environmental challenge, their work stands as a powerful lesson in resilience. It demonstrates that true longevity comes from harmony, from building with the Earth's own logic rather than against it. Their legacy is therefore twofold, a gift of indestructible stone and a blueprint for a more respectful way to inhabit our world. These silent stones are not relics of a dead past, they are a mirror held up to our own potential. The legacy of the lost architects forces a humbling but exhilarating question. What if our standard story of progress, that steady upward climb from primitive to advanced, is simply wrong? Their work suggests that profound innovation is not a monopoly of the modern era, but can blossom in any age, given the right combination of knowledge, need, and vision. This was not a linear march forward. It was a flash of genius that appeared, achieved the seemingly impossible, and then faded, leaving later generations to puzzle over its methods. This realization should not discourage us. It should liberate us. It proves that human creativity is capable of leaps that defy our own timelines and expectations. Confronting these mysteries cultivates a vital intellectual humility. We are reminded that our current understanding of physics and engineering is not the final word, but merely the latest chapter in a much longer conversation with the natural world. The builders of Puma, Punku, or Sacsayhuamán clearly possessed a different chapter, one written in a language of stone and resonance we are still learning to read. This humility is not about feeling inferior to the past. It is about opening ourselves to the possibility that other ways of knowing, other paths to technological mastery, have existed and may exist again. This is the true fuel for discovery, a restless curiosity that drives us to look deeper, to question established narratives, and to explore the vast, blank spaces on the map of human history. Every laser scan of a perfect joint, every geological analysis of a water-worn block, is an act of joining that conversation across the centuries. We are not just studying ruins. We are attempting to answer a challenge left for us, a silent dare etched in granite. By engaging with this puzzle, we tap into the same sense of wonder that must have driven those original architects to look at a mountain and see a temple within it. Their stones urge us onward, not to simply find answers, but to better appreciate the beautiful, enduring mystery of human capability itself. The silent stones of Baalbek and Puma Punku leave us with a profound enigma, a reminder that our history is a grand puzzle with vital pieces forever missing. These sites, where stones speak louder than any written word, consistently challenge our deepest assumptions about the past. They force us to confront the uncomfortable reality that our timeline of human progress might be incomplete, perhaps even fundamentally wrong. While we may never fully unravel the secrets of how these blocks were quarried, moved, and fitted with such impossible precision, the quest itself holds immense value. This journey into the unknown enriches our appreciation for the sheer scope of human ingenuity. It proves that our potential for innovation can flare up in unexpected eras, achieving wonders that later generations struggle to explain. Let these ancient wonders be a lasting inspiration, urging you to look deeper into the forgotten corners of our past and to actively question the established stories we tell about civilization's ascent. What other chapters of human achievement have been lost to time, waiting only for a curious mind to rediscover them? We would love to hear which of these mysteries resonates most with you, so please share your thoughts in the comments below. If you are eager to continue exploring the hidden stories of our world, subscribe to join us as we uncover more of history's untold chapters together.